Okay, so when we did our arrays yesterday, we had the restriction that you can only have one thing on the top axis, one thing on that side axis. You don't ever compare two events. Tree diagrams is another tool that we use to help us list sample space, but you can do a lot more than two things if you wanted to. We don't tend to do more than two or three because the tree diagrams just get way too big, but they do have the ability to do that if we wanted them to. So it says tree diagrams represent a sample space and can be used for many events, not limited to only two like the tables. So here is an example of a coin that is tossed and a dice that is rolled. Now you do one thing at a time. This tree diagram is drawn for you, but a lot of the time you're going to have to draw that yourself. So I'm starting with the coin. So I've put a heading at the top here, coin. When you flip a coin, you have two possible outcomes, a head or a tail. So you do that first branch, and they are your first two sets of outcomes. Then the second thing we want to do is to roll a dice. And we know that we have the numbers 1 to 6 on a dice. And we have to list those next to each one of our outcomes from the coin. Okay, so I have a head and I have 1, 2, 3, 4, 5, 6. Tail, 1, 2, 3, 4, 5, 6. That means that from that diagram, I can now list the outcomes or my sample space over here next to it. And all I do is read along what we call the branches. So this is head number 1. So I put H1 as my first outcome. Then it would be H2, H3, H4, H5, and H6. Then let's do the same thing for all the tails. It'll be tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So there are 12 outcomes that are possible when you flip a coin and roll a dice. From that, we of course will need to answer some probability questions. So question 1b. Find the probability of getting a tail followed by the number 3. So tail, then a 3, there it is. There is only one of them. So the probability is going to be equal to 1 out of my 12. That's it. You could, if you want to put some notation on there, you could put P for probability of a tail, then a 3. But you don't have to have that there, Charlie.
Do you always have to write P equals?
No. That's what I'm saying. So I could just put equals 1 over 12, or you can put the P in there if you want to. Okay, part 2. A head followed by an even number. So head and 2, head and 4, head and 6. So there is 3 of them out of the 12, which simplifies to 1 out of 4. Easy peasy. Next page. Remember how when we had our arrays, we had with replacement and without replacement questions? Same thing can happen for our tree diagrams. In question 2, it says a bag contains 8 red, and we're going to use the letter R for red, and 4 green, G for green, marbles. 2 marbles are got. Yeah, thanks. I should have changed that question, shouldn't I? 2 marbles are selected without replacement, which means once you select one, it reduces the number that you're selecting from for the second time. Draw a tree diagram to represent all the outcomes and probabilities. So this one, when I draw the first marble out of the bag, I know there's 12 marbles in that bag, but there's only 2 possibilities. I can either get a red or I can get a green. So the 2 outcomes I could get are red and green. This is for my first selection. Now, because those probabilities, there's not an equal number of red and green in that bag. In the first diagram, the head and the tail are equally likely, so I didn't have to worry about those branches being uneven in any way. But in this one, there's a different number in there. So this diagram is slightly different. I have to write the probabilities on the branches. For the red, there was 5 of them, not 5, sorry, there's 8 of them out of a total of 12. So I write that on here, 8 out of 12 chance of choosing a red, and there's a 4 out of 12 chance of choosing a green. Then I need to do a second choice. So second marble being selected from the bag. Again, I can either get red or green for each of my outcomes. I have to put that next to both of those branches there. The without replacement means if I have chosen a red marble, I'm going to do this branch first. If I choose a red marble first, I had 8 to begin with, there's only going to be 7 red marbles left. Out of no longer 12, there'll only be 11 marbles left in the bag. So there is 7 out of 11 red marbles left. But I didn't choose a green one, not on this branch. There's still 4 green out of 11 for this bottom one. Okay, other option was, what if I chose the green marble first? That means I'll now only have 3 green marbles left out of 11, but I would still have had all 8 of my starting red marbles. And it depends on what's picked first as to which branch you're going to be using. So here's the questions. Find the probability of selecting a red marble followed by a green marble. So red first, green second. I've put a tick next to the branch that I want. Okay, that branch in there. Red, then green. Okay? To find the probability, you times those numbers together. So probability of red and green, you don't have to have that notation there, but you can. The first number was 8 over 12, and I multiply that by the 4 out of 11. You multiply the numbers along the branch. And that makes, you can simplify it down to 8 out of 33. Okay, let's try the next one. What is the probability of getting 2 red marbles? So probability of red, red. So that's going to be the very top branch, red then red. Just like before, you multiply the numbers along the branch. So that is 8 over 12 times 7 over 11. Okay, so that comes out to be 14 out of 33 when you type that in your calculator. Part 3. Find the probability of getting exactly 1 red marble, not 2. So that first branch doesn't count, can't have that one, but I could have red-green, or I could have green-red. There's 2 possible branches there. Okay, so that means I'm going to find the probability of red-green and the probability of green-red. Now, if we know to find one branch, you multiply along the branches. But if I have 2 branches, then you need to add them together. So remember that. Multiply along the branch, but add branches together if it's more than one branch. So let's do that. Red then green. Red then green is 8 over 12 times 4 over 11.
Didn't you just have a plus?
Yeah, the plus comes now. So I multiplied along that branch. Now I'm going to plus the green then red means 4 over 12 times 8 over 11. And that equals 16 out of 33. Okay, there's another question on the next page that looks pretty much the same, but it's not.
With replacement.
That's right. So a bag contains 8 red and 4 green marbles again. 2 marbles are going to be selected, but with replacement. That means after I choose the first marble, I put it back in the bag so that I'm still going to have 12 marbles in there for the second selection. Okay, it's very important that you read the questions carefully to know when it's with replacement, when it's without replacement. So to draw this tree diagram, the first marble, I can have red or I can have green. this starts the same. I have 8 out of 12 chance of getting red, and I have a 4 out of 12 chance of getting green. For the second choice, this is where it's different. I can still have red, green, and I need to do it again, red, green. But because I put the marble back in, these numbers don't go down like they did last time. I'm still going to have 8 red out of 12 for the second choice and 4 out of 12 green. And I'm going to have 8 out of 12 here and 4 out of 12 there, because whatever you choose in the first time, you put it back in, so it's exactly the same for the second choice. Okay, now we want to find all those probabilities again with our new tree diagram. So find the probability of red, green, this branch. Remember, you multiply the numbers along the branch. So that is 8 over 12 multiplied by 4 out of 12. And that equals 2 out of 9. Sure, you can do the calculating part on your calculators. Part 2, 2 red marbles, which means I want to do this one up here, the red. So that's going to be probability red is multiply along the branch. 8 over 12 times 8 over 12. And that equals 4 over 9. And they're exact same questions. The last one is exactly 1 red marble, which means I can have the red-green or the green-red. So remember, add the branches together. So probability of red-green plus the probability of green-red is red-green was 8 over 12 times 4 over 12. Plus, so multiply along the branches, then plus green-red is 4 over 12 times 8 over 12, which is exactly the same. They are exactly the same, they're just in a different order. So you could just go times by 2 if you wanted to as well. But I will write it out again. Now there is another type of question that is not on here. Something that might save you some time. If you get a question that says, find the probability of getting at least 1 red marble. Okay? That would mean it could be red, green, or green, red. It could be all 3 of the top 3 branches, and I just don't want the 4th one. Now you can do similar to that last question that I did, where you add all 3 branches together. Can anyone think of an alternative? Oh, I can hear people whispering. No?
Times one of the minus.
Yeah. What you can do, the shortcut, especially when there's lots of branches, this is not a very big tree. Sometimes there can be a huge number of branches. If there's only 1 branch that you don't want, find the probability of that 1 branch and do 1 minus. So you go 1 minus 4 over 12 times 4 over 12, and that will give you the 3 branches that you do want.
Will it still work if you...
It will still work the same if you do all of them and add them all together. Okay, so you need to do 3F